day 44 of communication practice with ChatGPT. Morning, ChatGPT.
Chào Ngọc, có gì mình giúp không?
Yes, can you first speak in English?
Of course, I'll speak in English. What's on your mind?
I want to practice communication, especially in mock interview. Can you do that with me?
Absolutely. Let's get started. What kind of mock interview would you like to practice today? We can focus on a senior data engineer role or something else.
Yeah, I want to practice for the technical route of senior data engineer role.
Great choice. Let's dive into a technical round. I'll ask you a question related to system design, and you can answer using the STAR method. After your response, I'll give you feedback.
Okay.
All right, here's a question. Can you describe how you would design a data pipeline for real-time analytics on a large-scale e-commerce platform? Walk me through the key components, technologies you'd choose, and how you'd ensure low latency and high reliability.
Okay. For first, I would want to understand the requirement. If it's actually the real-time streaming data or the business just want the data available for like after minutes or even hour. That essentially decide the technical stack that we would use. Second, I would want to diagnose the source system behavior and the data volume. If the source is already has store data in a streaming manner, like in a Kafka topic, and the data volume is about 1 million message per day. That means we will design our architecture based on that. And third, I would want to understand how data is consumed and used for the report. And if it's um, real-time analysis, it means that the report might have to be real-time. So that's also a thing to consider. And then for choosing the technology, I would do the I would essentially for streaming there's um tech stack that we might use. For example, in AWS, we can leverage AWS MSK for Kafka topic management and uh, and AWS uh, Kinesis, which is based on Apache Flink for real-time processing. And also we could do OpenSearch for the uh, real-time reporting. And by leverage the on-cloud technical, we can ensure the data, the reliability of the platform, since um, they have the um, built-in um, built-in native uh, reliability and scalability mechanism.
Great start. You covered the importance of understanding requirements and data volume. You also mentioned choosing technologies like MSK, Kinesis, and OpenSearch, which are solid choices. A couple of tips. Try to be a bit more concise in explaining each step and highlight how you'd ensure low latency, such as using partitioning strategies in Kafka or optimizing Flink jobs. Overall, you did well. I'd rate your response around a 7. Keep practicing, and you'll get even more confident.
If you were to answer that question, how would you answer that?
Sure, here's how I'd approach it. To design a real time analytics data pipeline for a large scale e commerce platform, I'd start by understanding the exact latency requirements. If true real time processing is needed, I'd opt for a streaming architecture. First, I'd use a distributed messaging system like Apache Kafka to handle the ingestion of high volume event data, ensuring it can handle millions of messages per day. Kafka's partitioning would help achieve parallelism and low latency. Next, I'd use a stream processing framework like Apache Flink or Amazon Kinesis Data Analytics to process the data in real time. This would allow for transformations, aggregations, and enrichment on the fly while maintaining low latency. For storage and querying, I'd choose a real-time analytics database like Amazon OpenSearch Service or Apache Druid, which supports fast querying and dashboards. This would ensure that business users get real-time insights with minimal delay. To ensure reliability and fault tolerance, I'd leverage the inherent features of Kafka and Flink, such as checkpointing and replication. I'd also implement monitoring and alerting to catch and resolve issues quickly. By combining these technologies and practices, the pipeline would deliver low latency, high throughput, and reliable analytics to the platform.
Mm, that's very comprehensive. I wish I could give my answer, concisely and accurately and comprehensively like you.
Thank you. With practice, you'll definitely get there. The key is to break down your thoughts into clear steps and focus on the main points. Over time, you'll become more concise and confident. I'm here to help you practice as much as you want.
Yes, I am ready for another question.
Awesome. Here's another one. How would you design a fault tolerant ETL pipeline that processes data from multiple sources and loads it into a data warehouse? Describe the technologies you'd use, how you'd handle schema evolution, and how you'd ensure data quality.
Okay, that's a quite a big problem. So multiple sources. Um, Essentially, I would want to ingest it to the to a staging zone, so that if if there are some problem with the source system, and the data is on the staging zone is available and accurate, we don't have to create new connections and increase the load at the source end. And so uh, multiple ingestion job to ETL data to the staging zone, mostly for one transformation. And for and doing that, we can leverage some data um, data quality check like unit tests for development, and also data monitoring for the maintenance. And from the staging zone to the data warehouse layer, we would also have some ETL job to transform from those into the into and load into the data warehouse based on the data modeling that we want. For example, star schema, uh, and in dimensional data modeling. And to ensure the fault tolerant, um, essentially by using Spark, they have some built-in uh, fault tolerant mechanism when processing data parallelly. If a worker die due to some issues that might be recovered, for example network, it the remaining workers will still capable of um, processing and writing data to the destination. But still, for other fault tolerant, we can implement the backup retry mechanism. For example, I used to have um, this issue when there was too much glue jobs spawn, but in with limited available sources on AWS VPC. So the job failed due to glue incidents couldn't be uh, initialized. So for short term, we can do the backup retry. For long term, we can do uh, more. We can migrate to more VPC. So anyway, that's a fault tolerant part, and that's basically it.
Nice job. You covered key aspects like staging zones for data integrity, using Spark for fault tolerance, and implementing retries. You also mentioned unit tests and monitoring for data quality, which is great. To refine your answer, you could briefly mention schema evolution strategies like schema registries in Kafka or handling changes with tools like Delta Lake. Overall, your explanation was detailed and well structured. I'd rate it around an 8. Great work.
Thank you. I forgot the part about schema evolution. So, anyway, if you were to answer that question, what would you say?
No problem, here's how I'd answer it. To design a fault-tolerant ETL pipeline that processes data from multiple sources into a data warehouse, I'd start by setting up a robust ingestion layer. This layer would leverage tools like Apache Kafka or AWS Kinesis to continuously stream data from various sources into a staging area. For transformation and loading, I'd use Apache Spark or AWS Glue, which offer distributed processing and built-in fault tolerance. If a node fails, the job can restart from the last checkpoint without losing data. To handle schema evolution, I'd implement a schema registry to manage and version schemas. This ensures that changes in the source data structure are tracked and handled gracefully, preventing downstream disruptions. Ensuring data quality would involve multiple layers of checks, including unit tests during development and real-time monitoring for data integrity and freshness. This could include setting up automated alerts for anomalies and running data validation rules. Finally, I'd automate the pipeline with orchestration tools like Apache Airflow or AWS Step Functions to manage dependencies and retries, ensuring the data is consistently and reliably loaded into the data warehouse. This approach would ensure a resilient, scalable, and maintainable ETL pipeline.
Okay, got it. So I think that's all for today. Thank you for practicing with me, ChatGPT.
You're welcome. You did great today. If you ever want to practice more or need any help, just let me know.
Mm, yeah, sure thing. Thank you. Goodbye. Have a great day.